Biologists have documented an animal capable of finding, identifying, and swallowing its prey in exactly 120 milliseconds. Within that brief sequence, the animal spends just 8 milliseconds deciding if what it touched is actually food. That entire evaluation happens in a window of time far too narrow for the human nervous system to even register. This record belongs to the star-nosed mole. It manages this blistering speed without using its eyes. To operate as the fastest mammalian forager on Earth, it relies on a completely alternative sensory system to process reality in absolute darkness. This adaptation was forced by the specific geography it inhabits, the wet, low-lying North American swamps. Beneath the surface of those marshes, the soil is anoxic, completely starved of oxygen. The mud passages are prone to collapsing, and down below the waterline, the environment offers absolutely no light whatsoever. Surviving in wet earth creates a severe metabolic trap. The damp, cold ground continuously siphons heat away from the body, forcing the animal to maintain a furious, non-stop caloric intake just to stay alive. This extreme foraging speed is a requirement for survival. Every microsecond of efficiency keeps its internal furnace burning against the relentless chill of the mud. This ring of 22 pink rays is a dedicated touch organ. While it frames the nostrils, its primary function is to feel the shape of the world in high-resolution detail. This animated 3D map shows what is actually happening. The star is a highly compressed touch receiver. Packed into that tiny area are 25,000 microscopic sensory domes called Eimer's organs, all feeding data straight into a massive bundle of over 100,000 nerve fibers. As the mole sweeps its head through the dirt, those thousands of independent points of contact fire simultaneously. They assemble the textures and shapes of the environment into a detailed, continuous physical image. Notice how the system targets its focus. The mole uses the lowest pair of rays, the 11th pair, exactly the way humans use the fovea, the high-resolution center of our retina. It scans broadly with the outer edges, then zeroes in with those bottom rays for a sharper picture. The mole is never blindly fumbling. Its brain has been explicitly remapped to read the physical ground with the exact same precision that human eyes use to read a digital screen. But the soil is only half of its territory. Many of the mole's tunnels open directly underwater, forcing it to hunt in flooded passages. Mammalian biology dictates that smelling underwater should be impossible. Traditional olfactory receptors strictly require odor molecules to drift through the air to function. Yet biologist Kenneth Catania captured the animal bypassing this rule on high-speed camera. As it swims, it rapidly pushes tiny air bubbles out of its nostrils and sucks them back in against submerged surfaces, repeating the cycle 5 to 10 times a second. The pocket of air operates as an anatomical messenger. It physically touches the object, absorbs the scent molecules directly off the surface, and ferries that odor back into the nasal cavity to be processed. This is a proven, robust evolutionary strategy. We know this because another predator hunting in those exact same streams, the water shrew, arrived at the exact same technique entirely independently. Faced with the physical limitations of water, the mole engineered an answer by turning its own exhaled breath into a remote sensory tool. Running this high-speed hardware carries a heavy biological tax. Processing that massive flow of tactile data requires a brain and metabolism that consume immense continuous energy. The mole is physically locked into this one world. Its spade-like hands are designed for soft mud, not for travel across hard ground, and its extreme metabolism would crash in any habitat where prey isn't found every few seconds. It has traded the ability to live anywhere else for the ability to be the undisputed master of this single, difficult niche. We instinctively rank animals based on how closely they align with human sensory experiences, but an animal that operates without sight is not a lesser version of a sighted creature. The mole simply navigates an alternate reality. Its mind is perfectly tuned to a hyper-fast storm of tactile data that human biology lacks the equipment to ever genuinely experience. This sophisticated biological machinery operates in the mud of an ordinary marsh, just a few feet below where we walk. If you found this adaptation astonishing, take a second to subscribe. Let us know in the comments which animal's survival strategy surprises you the most, and tell us which ecosystem we should explore next.